Hi, welcome to part 3 of the video series about laws of motion. In the previous video, we have stated the first law of motion, defined inertia, and learned about the relation of inertia with the mass of an object. In this video, we are going to define equilibrium and then solve 3 examples to understand the equilibrium better. Equilibrium is closely related to the first law of motion. According to the first law of motion, an object will remain at rest or move with constant velocity unless an unbalanced resultant force acts upon it. In other words, if the net force applied on an object is equal to 0, the object will remain at rest or will move with constant velocity. Definition of the equilibrium is almost the same. If the net force applied on an object is equal to 0, the object is said to be in equilibrium. From these two definitions, we can derive that if an object is at rest or if it is moving at constant velocity, it is in equilibrium. In some books, the definition we have provided is named as translational equilibrium. But due to the fact that other type of equilibrium, rotational equilibrium, is not taught in CAPS syllabus, from now on, instead of translation equilibrium, we will use just equilibrium. Especially in grade 11 exam papers, one of these questions is related to this topic. So let's try to solve some examples to understand the topic better. First example is the simplest one. An object is hanged from a ceiling by means of a rope or string. We have to calculate the tension force on the rope. First thing first, if the object is in equilibrium, the net force on it will be equal to 0. Even though we have learned how to draw a free body diagram in the previous video, in this one we will use force diagrams, as we can come across this expression in some textbooks or even in some questions. The only difference between free body diagrams and force diagrams that in force diagrams we draw the object or box and then show forces on this object. But free body diagrams are free of body, so instead of an object or box, we just draw a dot. We start by drawing the box. We are asked to calculate the tension force, so as a second step, let's draw a vector representing it. Finally, we draw the force of gravity, and as usual, we draw it downwards. If we choose upwards as positive direction, tension force will have positive value and force of gravity will have negative value. Thus, net force is equal to tension force minus force of gravity, and this expression is equal to 0. Force of gravity can be calculated by multiplying mass and gravitational acceleration, which is equal to 9.8 meters per second square. In your exam papers, value of gravitational acceleration will be provided in the constants sheet at the end of your paper. As a result, tension force is equal to 49 newtons. Now, let's see a bit more complicated question. Two boxes are hanged from a ceiling as shown in the figure. We have to calculate tension forces on both ropes. There are different methods to solve this question. Some of them shorter and some of them are longer. But unfortunately, we can't get full mark in CAPS Aligned exam for most of these solutions. That's why we will stick to the standard method. These objects are in equilibrium, so net force on both of these boxes are equal to 0. Now, we have to draw free body diagram or force diagram and then write down equation for each object separately. Let's start with 5 kg object. There are only 2 forces applied on this object, tension 2 and force of gravity. If we choose upwards as a positive direction, the equation for this object will be tension 2 minus force of gravity is equal to 0. Force of gravity is equal to mass times gravitational acceleration. The object is 5 kgs, so after substitution, the equation will be T2 minus 5 times 9,8. As a result, tension force on the second rope is equal to 49 newtons. Now, let's follow the same steps for 3 kg object. There are 3 forces acting on this object. Tension 1 pulling it up, force of gravity pulling it downwards, and tension 2 is pulling it downwards as well. We recall that tension force is same on each point of a rope and acts on opposite directions for each object. So T2 pulls 5 kg object upwards and 3 kg object downwards. As we chose upwards as positive direction, the equation will be T1 minus T2 minus force of gravity. From the previous equation, we already calculated T2 as 49 newtons. And as this is equation for 3 kg object, after substitution, the equation will be T1 minus 49 minus 3 times 9.8 is equal to 0. As a result, T1 is equal to 78.4 newtons. The last example is the most complicated one. Again, we have a system in equilibrium, and we have to calculate the tension forces on each rope. One of the methods we can use is to calculate the components of each force and do required calculations. But there is a shorter method which can be used if we have 3 forces applied on one object and if the object is in equilibrium. To use this method, first we use tail-to-head method to draw vector diagram of these forces. You can click on the link above to review addition of vectors. You can add vectors in any order. We will start with the force of gravity. From the head of force of gravity, now we can draw T1. And then from the head of T1, we draw the last force T2. As a next step, we have to calculate the inner angles of the triangle. To do so, let's draw these parallels as our helper lines. In the figure, tension 1 makes 37 degrees with the ceiling. So the angle between the parallel and T1 also will be 37 degrees. Tension 2 makes 53 degrees with the ceiling. So angle of tension 2 and parallel line will also be 53 degrees. We know from the maths classes that alternate angles between two parallels are equal to each other. As a result, this angle is 53 degrees as well. Force of gravity and ceiling are at right angle to each other. So, to complete the angle between these two to 90 degrees, this angle becomes 37 degrees. Sum of inner angles of a triangle must be 180 degrees. So the last angle left is equal to 53 degrees. Once the triangle and its angles are ready, let's again seek help from the maths. According to the law of sines, if there is a triangle with the sides A, B, and C, as well as with the angles alpha, beta, and theta, ratios of a sine of an angle to the side opposite to the angle are same. So, sine alpha over A is equal to sine beta over B, and it's equal to the sine theta over C. Now, let's use this knowledge to solve this question. Angle opposite to force of gravity is 53 plus 37 is 90 degrees. So, sine 90 over force of gravity is equal to sine 37 over tension 1. And the same expression is equal to sine 53 over tension 2. Force of gravity is mass times gravitational acceleration. 5 times 9,8 is equal to 49 newtons. Now, sine 90 over 49 is equal to sine 37 over T1. If we leave T1 alone, it will be equal to 49 times sine 37 over sine 90. As a result, T1 is 29.49 newtons. On the other side, sine 90 over 49 is equal to sine 53 over T2. Thus, T2 is equal to 49 times sine 53 over sine 90. If you calculate T2, it will be equal to 39.13 newtons. In this video, we have defined equilibrium and tried to solve 3 examples to understand the topic better. In the last example, we also learned how to use the law of sines to calculate specific types of questions. In the next part of this video series, we will state the second law of motion and solve some examples related to the topic. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.